Hello, Math 1224. This is Dr. P with Lesson Launch 403. Here we go again, and possibly again. We're going to do one more example of an integral using the integral table. That integral is going to be the integral of x squared minus 4x minus 2 e to the 3x dx. Now that one looks kind of mean. It's got a quadratic and it's being multiplied by an exponential. Let's see if there's anything in the table that might help us out here. So again, I just sort of walk through here. These are all the basic ones. I don't think what I have is going to fit any of these simple ones here. Here I have exponentials and trig functions, but everything here is a product of either an exponential and a trig function or a trig function and a trig function. That's not quite going to do it. But if I look at this table, it says product of polynomials with natural log, e to the x, cosine x, and sine of x. That is a lot like what I'm working with here. I've got a polynomial here times an exponential. So I think if I look at this table, entry number 14 looks promising here. Now 14, you'll notice this shows two different things, and these are the same thing. This is saying, here's a rule that you might use if you want to rewrite the integral as this function minus a hopefully simpler integral. And then this is just an expansion of all of that. I'm going to model how to use this one. I'm going to pretend that this second expression here is not even there, and show how we could come up with the integral correctly just using this recurrence here. All right, so I'm going to start by entering the table number 14. And as I'm using 14, I just want to make sure and note that my p of x is x squared minus 4x minus 2. That's a polynomial. And my value of a is 3. All right, anyway, so getting started here. This is going to be equal to 1 over a, that's 1/3, p of x, that's x squared minus 4x minus 2, times e to the ax, that's e to the 3x, minus, okay, I can see this is going to become a space problem here, so I'm just going to copy this. I'm going to copy this one rule here and move it over so I can more easily use it. There we go. And just blow this up a bit so I have more room to work. There we go. Love it. Anyway, so that's my 1 over a p of x times e to the ax. Now I'm going to subtract 1 over a, that's 1/3, times the integral of p prime of x. That's, well, what is p prime? That's just the derivative of x squared minus 4x minus 2. That's 2x minus 4 times e to the ax dx. That's e to the 3x dx. Okay, and that's the first step. But now this is the here we go again part, because now I have another integral that I have to compute here. 1/3 times this integral of, well, hey, this is a polynomial times an exponential. That means I can use rule number 14 again. So I'm just going to drag this over here. This is going to follow us along like a lost puppy until we're done. So now I've got this one. I think I should probably give myself a little more space to look at this. There we go. So I'm just going to keep in mind here, I've got 1/3 x squared minus 4x minus 2 e to the 3x minus this integral here. Now, at this point, I'm going to try and simplify this. Well, now I'm looking at this integral, and now I'm going to use rule number 14 again, using p of x equals 2x minus 4, because now that's the integral, or sorry, that's the polynomial I'm multiplying by the exponential. And again, a equals 3. A is going to equal 3 the whole time here. All right? So I'm going to be subtracting 1/3 times whatever that integral is, and it's going to be 1 over 3 times p of x, that's now 2x minus 4, e to the 3x, and then minus, let's see if I can drag this over here. There we go. (3x) minus 1 over a, that's 1/3, integral of p prime of x. Well, now p of x is 2x minus 4, so p prime is just going to be 2 e to the 3x dx. And now this is starting to look really gnarly here. It's hard for one step of this calculation to fit on my screen. But the good news is I'm just about done, I think, because now I know how to compute this integral. I don't need a table to do that anymore. So I'm just going to clean up a little bit here. I'm going to get rid of this integration rule so I can work. There we go. I'm just going to kill that. All right, and now just going to simplify this a bit and get 1/3 x squared minus 4x minus 2 e to the 3x minus 1/9 2x minus 4 e to the 3x. And then here I've got a subtraction here and a minus sign here. So this next term is going to be positive once I lose the parentheses. Plus, so that last term, you'll notice I have a factor of 1/3 here, a factor of 1/3 here. So I'm going to have plus 2/9 integral 2 e to the 3x dx. And now simplifying just a bit more, I get 1/3 x squared minus 4x minus 2 e to the 3x minus 1/9 2x minus 4 e to the 3x plus, and then integrating this part here gives me 2/9 times 2/3. Sorry, that's a little bit sloppy there. 2/3 e to the 3x plus c. All right, so now I'm going to do a little bit more simplifying and get 1/3 x squared minus 4x minus 2. You know, I know that writing this feels like a pain, but I have to tell you, writing this on a tablet while recording my voice feels like even more of a nuisance. But now I have a little bit more empathy for what you go through when you have to work one of these. This comes out to 4/27 e to the 3x plus c. Okay, and I just want to mention, I could also, if I wanted, I don't think this should be mandatory, and I think you'll probably agree with me, but all of this stuff here, when I look at this term, and this term, everything here has a factor of e to the 3x. I could factor that out and just combine this polynomial with this one and with this one, this 4/27 here. And I think, I'm not doing this extremely carefully, but when I look at my x squared terms, I get 1/3 x squared here, and then that's the only x squared that I have. So I believe I have 1/3 x squared, and then looking at linear terms, I have minus 4/3 here, because there's a multiple 1/3, minus 4/3, minus 2/9. What's that going to come out to? That's like, I think it's minus 8, no wait, let's see, minus 12/9, minus 2/9, that's minus 14/9. You may have to check my arithmetic here. And then finally, I've got minus 2/3 here, plus 4/9 here, plus 4/27. So, goodness gracious, minus 2/3, that would be like minus 18/27. And then plus 12/27, so I think I'm up to negative 6/27. So I think, God help me, this is probably minus 2/27. All of that times e to the 3x. I'm going to level with you here. I'm not being super careful about this part because really I feel like it should probably be a violation of the Geneva Conventions not to allow you to leave things like this. Yeah, in principle, we ought to be able to let a calculator or a computer handle the rest. But I think if you were to simplify everything, you would probably get this. Feel free to check my work and let me know if that turns out to have been wrong. But I actually like this form because all of this work should feel reminiscent of something. I'm going to zoom way out here so we can see the whole the whole battle from the top of a hill here. You'll notice everything here had sort of the flavor of an integration by parts problem. I started with some term that didn't have an integral, And you'll notice that term had this p of x here, and then e to the 3x times 1/3. That's the integral or antiderivative of e to the 3x. So that's like the first step of that integration by parts process. And then what I have here, sorry, what I'm looking at here, that's that minus v du piece. The 1/3 has been moved out, but the rest is just on the nose. It's the integral of v du. And then here, when I expand this, I'm performing integration by parts again. So really using this table is like using integration by parts twice. Now, just as a reminder, if I go back and look at the table here, I was using entry number 14. I could have just used this non-recursive formula that I'm mousing over here. And that might have been a little bit faster. You'll notice there's these coefficients of 1 over a, 1 over a squared, 1 over a cubed. And those are going to pop up here as well. Okay, zoom out. There we go. You'll notice those are the same things that we're seeing here with this 1/3, here with this 1/9. And then the other one's kind of buried, but there's a factor of 1/27 in there. It's just I also brought those factors of 2 along. So I just want to point out there's a few different ways of thinking about this problem. The recursive one is only one of them, but I wanted to demonstrate how to use the table recursively because there are some entries in the table, like these for example, the ones you see here, for which there's only the recursive formula given. There's no explicit formula. So anyway, that was a mouthful, but that's the end of this example here. Be grateful you only ever have to do that once, or at least watch me do it once. I'll probably make you do one of these just as an initiation, right? But there you go. The next video will focus on partial fractions and introduce that process. So look forward to it.